Even before we get to treatment, we need to get people diagnosed. And I'm hoping that this has a direct impact on that speed of diagnosis and will help lots of people. Unfortunately, Wales have one of the worst cancer mortality rates in all of Europe, which is actually quite a shocking result. So I'm Burhan, I work at Cardiff University and I work across the schools of computer science and the School of Dentistry. So I work on automated cancer diagnosis. So patients will come into the NHS and if they're suspected of having cancer, they might have a biopsy done in their lymph nodes to check if that cancer has spread. And so I work on developing algorithms that can look at those images and automatically find that cancer in order to speed up the diagnosis process and reduce workload on pathologists. So it's a lot of computational work because I work with these images, obviously. And so I just kind of open up my laptop. I work on lymph nodes and lymph node tissue specifically. And when cancer gets into the lymph nodes, it's called metastasizing. The cancer metastasizes into the lymph nodes. And these metastases have three main types: macro, micro, and isolated tumor cells, ITC. And macro and micro, they're differentiated by size. ITC is the smallest type of metastases. Macro and micro ones are easy enough for pathologists to find. They don't super struggle with these. ITCs, on the other hand, are very, very small. These images are hundreds of thousands of pixels, maybe even billions of pixels. And these ITCs occupy a couple of those pixels. And so it's literally like finding a needle in a haystack, but actually the needle is a cell. The haystack is also cells. So you're looking at a stack of needles. No, you're looking for a needle in a stack of needles. The first kind of bottleneck in that cancer diagnosis in Wales and the NHS in general is that there are a lot of patients that come through cancer as a rising disease. Basically, more and more people have it, but at the same time, there is not enough pathologists in the NHS working on doing this diagnosis for various reasons. Basically, there just isn't enough pathologists. And when they're looking at these biopsies, and this is the computational problem, these biopsies are huge images, so they can be hundreds of thousands of pixels in dimension, which means that there's billions of pixels in these images, which is a lot, and sometimes these cancers can be just a few pixels wide. And so when they're looking for these cancers, they can spend up to 5-6 hours per image just finding the cancer. And if you think about there being multiple patients, which each have multiple biopsies, which have multiple slides each, that's a lot of slides and a lot of time taken on this diagnosis. And so there is a need to help speed these things up with some automation. So it's a lot of computational work because I work with these images, obviously. And so I just kind of open up my laptop, open up these images, and then I've got various projects going, all which have to do with various different techniques that I have in mind for how we can actually use computer vision and those techniques to find the cancer in these images. And then it's just, some days it's very deep work where I'm coding, I'm running pipelines, I'm trying to figure out results and stuff. And a lot of the other days, it's a lot of just admin firefighting or debugging and things like that. So I have a computer vision, mathematics, computer science background. And I did work in startups and tech before I did the PhD. I also did a bit of work for intelligence. Throughout that entire time that I was working there, it always felt like the things I was applying my skills to were not the most beneficial ways of applying AI to humanity, whereas the application of AI to cancer diagnosis to these medical applications, I feel like is one unequivocally pure and good application of AI to cancer, and I feel good doing it. Near the start of the research, when I was doing a lot of the reading and things, it became very clear to me very quickly that despite the field of AI in medicine moving so rapidly forward, and even in pathology, there are lots of state-of-the-art models which are trained by Google, Microsoft. They have millions of data sets, millions of examples. They've like got models that are insanely powerful that I could never hope to achieve by myself and stuff. But even with all of this existing, this problem of ITC detection is still a completely unsolved problem. And so just realizing that there is this niche, which just myself working on it can make some progress, that was a breakthrough. In terms of the actual methods to do that, I'm still exploring, and hopefully there'll be breakthroughs there soon.